Hello everyone, welcome to another episode of Visual Studio Toolbox happening right here in the studio.
Yeah.
I'm your co-host, Leslie Richardson.
And I'm your co-host, Robert Green.
Yep, and today we are continuing our series on automated testing, joined by Phil Japixi, who's going to be sharing a lot more and doing a deep dive into what automated testing is and how it works and the software tools that you can use to make it happen. So, Phil, in the last episode, we just sort of dove in to why automated testing is important, but I don't think we actually talked about what test-driven development is, which is also another important term for what we're going to be talking about.
Correct, and we didn't talk about it, and it is very important. So test-driven development, the whole concept there is you're writing your test first, right? So, excuse me, it's red, green, refactor is kind of the mantra. Not kind of, it is the mantra. So I write a breaking test. And if you want to look at the training wheels version, that's like, I'm going to test this class. The class doesn't exist, so I get a compile error. So it's a failing test. So now I'm going to make the class, right? And then I'm going to actually call the method, and it doesn't pass, right? Because the method doesn't exist. But what we want to do is we want to write our expectation, right? Our acceptance criteria, if you will, for this section of code. And it's a unit test, so it's a unit of work in C#. That's a function, right? And we write that first. Again, we talked about this briefly. We kind of danced around it. But the reason we do that is so that we write less code, right? Because I only need to write enough code to make this thing pass, right? I'm not gold plating. I'm not adding additional stuff. Here's the requirement. I've written it, right? So it's test-driven development. But really the thing I want to point out more importantly is it's not about the tests. The tests are kind of a side effect. What really we are doing is we're developing code with an emergent design, right? So instead of sitting at this blank canvas and not knowing where to start and just randomly typing code, we're laser focused. Here's the thing I want to fix, right? So I fix this or I build this the first time. And now it's emerging, right? The entire application is merging through very thoughtful methods as opposed to just banging on the keyboard.
Okay.
Right? Mm-hmm. There's test eventual development, which is what most of us find ourselves in, is where we have our code. We realize we have no tests in place. We have to go back and add that code, right? And again, I want to point out Michael Feather's book, Working Effectively with Legacy Code. He has great examples of how to do that refactoring.
Awesome.
So one thing I want to point out, and let's talk about, well, actually before we get into the AAA syntax or arrange, act, assert of test-driven development, let's talk about XUnit.
Yeah, yep. XUnit is actually the topic for today's episode. So what is XUnit?
So XUnit is the next evolution of NUnit. So most of us in the .NET framework space are familiar with NUnit. Great testing framework, but there were some problems, right? There were some things that were acceptable in the testing community when NUnit was built that really have emerged as anti-patterns. For example, exception handling. In NUnit, you can have an attribute on your test that says if this exception is thrown, then the test passes. The problem is that the exception can be thrown anywhere, and it's a passing test, not necessarily thrown by the system under test.
Okay.
Right. So the makers of NUnit, and a lot of them went on to build XUnit, which is the next generation. Fix that. Right. So you don't have this holistic exception catching thing, right? You have an action and then you throw the exception there, or you're checking to make sure it gets thrown with the action, right? So it's more laser focused. There's some other changes as well. But XUnit was the first one that adopted or was compatible with .NET Core. So while they're both available on framework, right, XUnit was the first in with .NET Core, and so that's the one I stuck with. I was already using it in framework. And so it was just a logical thing to move to XUnit. So not saying that the other frameworks are bad, I just prefer XUnit.
Yeah, makes sense.
So you probably want to see some XUnit. So
Yes,
let's dive in, right? So let me talk about, first of all, what do you need to have XUnit? Now there is, the .NET Core team has also adopted XUnit. So there is an XUnit template.
Great. Yep.
So I can do .NET new XUnit. Or I can do right-click in Visual Studio, file new project, and pick the XUnit template.
So does XUnit get installed with Visual Studio now, or is
It does
this
not. It's a
after
package.
you go get
It's
the
a
NuGet
template,
package?
right?
Okay.
If you go get the NuGet. And that's why I'm bringing this up. So what happens is you get the Microsoft .NET Test SDK, And then you get these packages as all part of that template,
Okay.
right? What I've added in is fluent assertions, and we're going to talk about that probably in the next episode, right? And then I also add in the threading analyzers. Nothing to do with testing, right? It's a great package. It's I believe it's Roslyn based, and it just kind of checks your work with the way to async calls to make sure you're not doing an anti-pattern.
Oh, awesome. Yeah.
Right? So I just throw that in all the time. And then we're going to have at least 2 episodes on MOQ, but we're not going to talk about this in today's episode, but this is my standard layout, right?
Okay.
This is the kit that I build whenever I'm doing testing.
Cool. I was going to ask what MOQ stands for, but we can save it as a teaser for the next episode. Right.
Yeah, you know what? Because I'll have to look up what it stands for because I know it's a mocking framework and I don't know if it actually stands for anything or not. So stay tuned to see if Phil can answer the problem.
Oh, yeah.
So once we have XUnit installed, what we do is we get an attribute. There's 2, and we're going to talk about this in a little bit, but there's facts and there's theories. And if you think of back to NUnit or MS test, this is a test,
Okay.
right? And then so tests they have to be public. They should all be void. Actually, they have to be void. They can be async as well. But let's just do something, right? And actually, we should probably call it should return the sum. Let's be a little more specific, right? And we'll write a very basic test. So the AAA syntax was developed long ago, and it's a pattern for building unit tests, or tests in general. So you have your arrange, act, and assert. Now there's some rules. So you can have as much arrangement as necessary to set up what's called your system under test. That's the thing that we're testing. But you only ever have one action. If you have more than one action in your test and the test fails, you don't know what action broke it, right? And so another advantage of having these automated tests is when a test fails, you know this method is broken, right? It kind of defeats the purpose of saying, well, now I have to debug it and run through at runtime to see which of the 2 methods failed, right? So we're going to arrange first. And like I said, this is going to be a very basic test. And we're going to say addend 1 equals 2. And addend 2 equals 3. I'm still not sure if I'm happy with how Visual Studio reads my mind.
It is kind of freaky initially.
Right.
Oh, look, there it goes.
Yeah, there it goes again.
Awesome.
And then we're going to have an action, right? And that action is we're just going to var sum equals addend 1 plus addend 2. And
So-
then
Just for clarification, so in arranging, it's kind of just like defining your variables or other...
it's creating, and you'll see it when we get into more complicated tests. It's setting up your mock instances of your interfaces, right?
Okay.
It's creating the instance of your system under test, right? So if I had a calculator class, that would be, var c equals new calculator type thing, right? So arranging anything you need to execute the test.
And that could even be as complicated as making a database call and bringing back data.
Correct.
Right? It's just
There's a better way of doing that, which I'll show you, but yes, it can be that complicated.
Cool.
All right. So then we have wow, it really is taking over my computer. Then we have our assertion. And what we're doing is we're asserting what happened, right? And there's the state assertion, right? In this case, is the sum equal to, and this is wrong. Oh, so Visual Studio is wrong,
Oh, it tried.
right?
Yep.
And this is really not what we want to do because here's our expectation,
right.
Right.
Okay.
and then here's our actual. And if we look at the IntelliSense for it, right, we have expected and actual. Now, here I'm going to introduce a little controversy because there's a fair number of people who said you should only ever have one assertion per test. And I'm going to say I disagree with that. I totally agree, can't have more than one action, right? It's got to be the Highlander principle, there can be only one. But from an assertion standpoint, I'm going to assert the state, I'm going to assert the behaviors, right? As we get into more complicated testing, we'll see that. And so I want to make sure, and very seldom does real business code just do literally one thing, right? A calculator does one thing, it brings back the sum of 2 numbers. But let's say that I'm actually processing an intake lead. right? You know, a new client lead coming in is not just saving to the database, right? It's got to compare to see if it, the client has already called us. Right? All these other things that have to happen, right? So we're going to get some comments that you should only have one assert, and if that's how you feel, more power to you. You're going to see in my examples that I'm going to do as many assertions as I need to make sure that I'm happy with the results, right? Now we can run this a number of ways. If we go up to test, let me save it. Test Explorer. And XUnit examples. Anybody have any idea what I called it? I have no idea what I called it. First example. Nope. My first test. There's one test in here. Should return the sum. It also works with the .NET CLI. It works with ReSharper. It works with, I can't think of the CI/CD project at TeamCity. So here I have run the test. It passed. Right? No errors, no warnings. Right? Mm-hmm. Now, if I right-click and say run all unit tests, it runs. If I go to the command line and say .NET test, it'll run those tests, right? So now we have this automated process.
And does it also work with the live unit test running that's in?
It does.
Visual
It does.
Studio?
I don't have it
Which
turned
might
on
be an
because
enterprise feature, if I'm not mistaken.
Yeah. I mean, last time I checked, it was an enterprise feature, but.
But it would work with
could
that if you
change.
had that, right?
Yeah.
yeah, I'm afraid I'm not going to turn it on because you'll see the lights will dim and everything else because it takes a lot of CPU cycles to do that.
There's pros and cons to it, for sure.
But yes, it does work with that, right? Because so when you look at the project setup, right? There is the XUnit Runner Visual Studio, so that plugs into the Visual Studio framework.
Okay.
So, all right, so we're good with the basics, right?
Yeah.
And now you might be wondering, well, what's a fact, right? Why is it called fact?
Right.
They actually have a really good blog post on this, and so I'm going to say it in my own words, which is not theirs. But a fact is, I am saying this thing is going to happen this way. Okay?
Okay.
We also have theories. And a theory, if you think of what we want to compare it to historically, this is a row test in XUnit, if you're familiar with that term. MS Test never had this capability, it might now. And what it allows us to do is, through a variety of mechanisms, including database calls, we can get different sets of test data. And so now we're testing a theory. In theory, this calculator will add two numbers together and bring back the sum. And what you want to do is you want to do something that's a little more important than just testing two numbers and have it brought back, right? And the reason I like this much more is now I can start testing edge cases, right? So again, we've got a very simple, we're just adding them together, we're asserting the equal, but we're passing the data into the test, right, as parameters. So now what happens if I do this and I say I want to do int.maxValue and int.maxValue, right? And now I can run this test, and you might be saying, who would type in the largest integer possible into a screen? And I would like to just say, have you met users?
Yeah.
Right? So now I'm going to run them.
We like to break things.
And here's the other thing that you'll notice, right? I ran one test, but each theory gets reported as its own result.
Okay, that's
Okay.
cool.
So then I go into here and I say it actually is -2. So if I add int.maxValue to int.maxValue, I actually get -2.
Oh, interesting.
Which you think about how overflow works, right?
Yeah.
And I'm not doing overflow checking. That actually makes sense, right? More importantly, when we get into behavior checking, if we're going to hit an overflow, we should probably throw an exception. Make sure the exception gets thrown and things like that.
Right.
Okay? So that's the difference between theories and facts.
And again, theory, fact, inline data, all these attributes are provided by XUnit.
provided by XUnit.
Okay.
Inline data doesn't exist anymore. I was making a reference to what NUnit called
Oh,
it.
okay.
Right. Oh, sorry.
Wait.
Yeah, no, you're right. Inline data. I was thinking row test.
Okay.
Oh.
Yes.
Right.
I know, the look on your face was
I
like,
was like,
I'm
what is
looking
that?
right at
Yeah,
what you wrote.
like that's not.
The code just worked. What do you mean it's not
It
provided?
just worked. No, I was thinking of row test, which is
Okay.
what it used to be called.
Got it.
Because then it would be test data, right? I'm trying to remember back to. So if you're coming from or NUnit, those would be the translation points. We can skip. This is the same as ignore. Typically, this is an anti-pattern. Because if you have a test and the test is failing, you shouldn't just ignore it to get through the day. You should fix why it's failing,
Sure.
right? Sometimes sometimes it's okay to do an ignore if you know you can get back to it, right? Like real life happens, right? You've got to push something out. There's a problem in production. You fix it. You got these other tests that are failing for some other reason. Should you push production if you have failing tests? That's a business decision, right? What is failing? Is this thing more important than that thing, right? So it's built in there, but we don't like to use it.
And then the message that's being displayed, if we're skipping over it, is that just like when we run all these tests, is it going to leave that message saying like we skipped it or something like that?
It is right here.
Okay,
It ignored.
got it.
Right. So what happens here, passing over because it has to fail to show the message. That's a lot of words. But if we look at it, right, there's the skip message and shows up in a test runner.
Okay.
Right. We can also change the display name. So some of the test runners, and this is a Visual Studio test runner, it's the name of the method, right, that gets displayed. When we talk about MSpec or machine spec and behavior-driven development or design and testing using a BDD framework, that test runner actually takes the name of your method and puts spaces between it. And so it's much more readable. So you can actually create an output to show to your business and say, this is what I'm testing, right? And so what you can do in XUnit is put a display name in there. And then depending on how you are outputting it, right, there's the ignored test custom display name. So it actually shows in the test runner the display name,
Interesting.
right? A couple other things I want to get to. I know we're trying to keep these episodes short, so let's get the structure down. Prior testing frameworks had setup and teardown, right? So there was test setup and test teardown, and then fixture setup and fixture teardown. What test setup is a method or chunk of code that runs before any test is executed. So it's gonna, if you got 10 tests, this code runs 10 times. It's going to repeat itself, right? Test teardown's the same way, but it's after the test is run. So why would you do this? Well, in the very simple stuff we're doing here, you wouldn't. But let's say when we talk about integration testing, which isn't unit testing, but it's still automated testing, I want to have the database clean up after itself between each run so that I know that this test didn't affect this other test. Because that's also very important in automated testing, is you can't be order dependent,
Right.
and you can't have, oh, this test can't break anything else. We have to return the system under test back to where it was. So if you're writing files to the file system, you have to delete them after you do it, right? If you're deleting data, you need to put it back in. So I have a sample data initializer, and we have a session that we're going to do like 4 or 5 episodes from now on integration testing, where we want to make sure that after or before the database is run, we refresh it so we have the same data. So we know there's 5 customers, 4 vehicles, 3 makes,
Right.
right? And so that's set up. The way it works with XUnit is that's just the constructor. So if you have a constructor in your test class, it will run before any test is run. If you implement dispose, then that code will run after any test is run. So you don't have to have this special method marked with setup or teardown, right? It's just the constructor runs. Because what's happening is every test that's run, it's creating a new instance of your test class, right? So this first example class, if we want to look at it and put it, and I think I have a demo of this that we may or may not get to, I put a counter in there, right? So every time the constructor is run, every time the dispose is run, right? And that counter is going to match the number of tests that's run. So it completely rebuilds the test. So that's how setup and teardown works. You can also do fixture setup and fixture teardown. We're probably not going to get into it. It's documented pretty well, but that's commonly referred to as an anti-pattern, because typically you don't want to have these 10 tests that are related depending on some outside thing. Now, in integration testing, I'm going to show you, right? This is why everything depends, because I want to make sure I actually have a database, right? And that the database exists and all the migrations have run. I don't need that running before every test, but I need it running before the first test, right? So I'm going to actually show you how to do a fixture setup in a later episode.
So in terms of running it first or after, I guess it depends on the scenario. If you just need some data, you could set it up ahead of time and then run the test, and then who cares? You're just going to reset it up. If other people are sharing the data, you need to set it back to its original state. You'd probably lean towards doing it after the fact. What scenarios does it matter? When does it not matter?
So that's a great question. It matters if the test needs it, right? So if your test needs it, let's say you're parsing a text file, right? In your setup, you're going to verify the text file exists.
Sure.
Does this file exist, right? And you probably have something to create that text file so you know what's going to be in it, right? Dispose is, have I cleaned up after myself, right? So let's say that you're creating a text file. It's a log. You're testing your logging framework. You're testing Serilog, and Serilog's writing to the file system, right? And it's a rolling file. You want to make sure that this message is in there. Well, now you've created a log file on the file system, and how does the test know if test A works and creates a log file and doesn't delete it, and what the test is asserting that this file exists, and then you run that test later, but it didn't actually create it because there was a problem, the file still exists, so the test would pass, right?
Okay.
So dispose, teardown is I'm cleaning up after myself. I want to make sure that campsite is cleaner than I found it.
Got it. Okay.
Right? Setup is I'm going to put my tent up before I sleep in it.
Okay.
Does that make sense?
Yeah, that's actually a great way to think about it, because then you don't have to sit there running through the scenarios. Well, does it matter? Because if the file exists, then I'll delete it.
Right,
If
I
it
have to
doesn't
do all
exist, then
these
I'll create it.
FKCs that-
No, create the file, delete it when you're done.
Yep.
It's much cleaner. I love that.
Yeah, and another nice thing that it's kind of hidden in their documentation, there's this test output helper. And if we look at it, so I'm using it to write additional comments. So let's run this first without it. Right, and it says success, and it says it passed, right? So there's the name of the test, first fact, there's success, right? There's the status, and there's that fact that it passed. So let's put the, put a little message in there, and then we're going to run it again. And so now our log, and we can actually output these logs to a text file, right, or any format we want. So now you're actually getting something more meaningful, right, as opposed to just it passed. And I'm getting told that we are at time for this episode.
I was trying to do it surreptitiously, and then you called me out.
Well, Robert had talked about it. We had actually thought about, because Robert and I, when we get on these shows, we tend to talk a lot. So I thought about bringing an old school alarm clock, with the little hammer
Yeah.
going.
Oh, yeah.
So it would go off at time, and it'd be like, oh, yeah, there's no hiding that.
Nope.
All right, so let's wrap up. Let me make sure before we wrap up if there wasn't anything else that we wanted to cover in this. And no, I think that's pretty much the basics. So what we're going to dive into is more of how you would really, right? So there's the basic framework. So let's dive into some real testing scenarios in the next episode.
Cool.
Sounds fun. Yeah, so tune in for some real-world examples on the next episode of Visual Studio Toolbox. And until then, happy coding.
Yep, see you then.